Skier up an incline. In this problem, we're going to look at a weird situation here. Imagine you've just skied down a hill, and then you come to the bottom of the hill, and there's a little hill where it goes back up at the bottom. So maybe you're like up here, and you skied down, and then you came down to the bottom, and then you're going to go up a little bit of a bump here. And we're going to say, based on the speed that you start up with here, how far up the hill are you going to get? So a skier is traveling up an incline at 5 meters per second, so V1 equals 5.0 meters per second. The incline has an angle of 25 degrees, so we're assuming that this is 25 degrees. The coefficient of friction between the skier and the ground is 0.2. Determine how far up the incline the skier will travel before stopping. So the first thing we're going to do before stopping, and we want to know the distance, how far up the incline. So what we're missing here is we're missing the acceleration. So we're going to go and do the incline problem to determine what the acceleration of the skier is, and then we will use it to solve the kinematics problem. So there's our incline at 25 degrees. Here's our object. We don't know its mass, so we'll just label it m. There's some force of gravity acting on him. We don't know how big the mass is, so we're just going to call that 9.8 m for now. That force of gravity can be thought of as a force of gravity that is perpendicular to the hill and a force of gravity that's parallel to the hill. If this is 25 degrees, then this is 90 minus 25, so this is 25. And so I can find out my FG perpendicular and my FG parallel. There's a normal force that will be balancing out my perpendicular component of the force of gravity. It can't balance out this parallel one because it's not pushing into the incline, but it will balance out the perpendicular one, and those two things are going to lead to a force of friction. Since the object is moving up the incline at 5.0 meters per second, then the force of friction will be opposing current velocity, and as a result will go down the incline. So let's just work our way around here and find all these things. FG perpendicular will be 9.8 m cos 25. FG parallel would be 9.8 m sine 25. I'll just hit both of those on the calculator. 4.1 m. And 8.9 m. So the normal force is equal and opposite to the perpendicular component, so that's going to be 8.9 m. So with that in hand, I can use my formula for my force of friction, UFN, which is going to be 0.2 times 8.9 m. It's 1.8. 1.8 m. And now I've got all the values of all my forces. I'm going to be a little careful here. I've called this my positive direction by calling that velocity positive. So then that means that this is negative. And if I look carefully, that means my force of friction and my force FG parallel is negative. So those are the two forces that are working together to change the speed of the object. All the other forces are balanced. So my net force is equal to my force of friction plus my force of gravity parallel, so negative 1.8 m plus negative 4.1 m for a total of 5.9 m negative. F equals ma, so negative 5.9 m equals ma. Usually you can't divide by variables, but since I know that the mass does not equal 0, the skier might be light, but they don't weigh nothing, I can go ahead and divide by those masses and recognize that my acceleration is negative 5.9 meters per second squared. Now I have my initial velocity, my final velocity, and my acceleration. Just ran out of room on my page, so I'm just going to slide up here. And recognize then that the equation that relates all the things that I have to the thing I want is 2AD equals V2 squared minus V1 squared. So 2 times negative 5.9 meters per second squared d equals I want to come to rest from a velocity of 5 meters per second. So on this side, negative 11.8 per second squared d is equal to negative 25 meters squared per second squared, dividing both sides by your negative 11.8. My distance works out to be 2.1 meters. So I wanted to figure out how far up the incline this guy would go before stopping. So I started with his initial velocity and his final velocity of 0, but I was missing an acceleration. So I'm going to go and use my forces to find that acceleration. Since he's on an incline, his force of gravity isn't completely canceled out by the normal force. We get the parallel and the perpendicular component, the parallel leading to acceleration, the perpendicular leading to the normal leading to a force of friction, taking the two forces that are unbalanced and using them to find the net force, the acceleration, and once you have the acceleration, the distance traveled by the skier.